Hi everyone, I hope you're doing well. So in this video, we're just going to discuss the Leetcode problem today, and today's problem is reduction operations to make the array elements equal. I don't know like why Leetcode has this obsession with making like huge problem names, but anyways, it is going to be a medium level problem, and I believe it is somewhat a newer problem because there are very few summations on this problem as compared to other problems. Right. So anyways, the problem says that we have been given an array and we have to make all the elements in that particular array equal, right? And how we can do it? We can take the largest number in the array, the largest number that is currently present in the array, and if there are multiple such numbers, we have to pick the smallest index one, right? So you will realize that it doesn't really matter which one we take, but they have just mentioned it so that we have one element to choose. Now once we have chosen our element, we can take the next largest element that is strictly smaller than the current number. So let's say if we have taken 5 as the largest number, we cannot take 5 as the next largest. We have to take some number smaller than 5, and that is strictly smaller. Now that we have taken two numbers, we will convert the larger number into the smaller number. So basically, let's say we have 5, 5 and 5 and 1, 1, 4, let's say, or 3, right? So what they're essentially saying is we have to pick the largest number. In this case, the largest number is 5. Now, if there are multiple choices, they have simplified a choice by saying that we can pick the smallest index one. So let's say we pick this one. This is one. This index is I. Now we have to pick the next smallest number. If this is 5, then we cannot take any other 5, right? That is for sure. We can take the number that is just smaller than 5, and that is 3 in this case. Once we have chosen these two numbers, we have to replace this particular bigger 5 by another 3, right? So the numbers will look something like this now, right? So we are always changing a bigger number into a smaller number. So one thing is for sure, that at the end all of the numbers will be equal to the smallest number in the input array, right? This thing is for sure. Now what will be the number of operations required to make this happen, right? So let's say this list is sorted, this array is sorted, and we have some elements like this. That means converted into B as well, right? So we have some elements and this list is sorted. That means A is less than B and B is less than C and C is less than D, right? So that means first of all, I'll have to take the largest number, that is the number of D's, right? Now at each operation, I'll convert one of the D's into C because that is the next smaller number than D, right? So I'll convert them one by one. So what will happen in the first operation? The list will look something like this: C, 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 and then D, D, D. Right. What happened essentially was one of the D's with the smallest index was converted to C. Similarly, in the next operation, this D will also convert to C, and then this D, and then finally this D. So all of them will be converted to C. Now you will see the largest number has become C now, and the next smallest number is B. So all of these C will convert to B one by one, and then all of this would have become B's. Now all of those B's will convert to A one by one. So what is essentially happening is all the greatest number are getting converted into just a smaller number. So how do we find the number of operations from this particular observation? You will always realize that in one operation, all of the numbers that were equal to the largest number will get converted into this one, right? So how many operations did it take? It took 4 number of operations because there were 4 D's, right? Since there were 4 D's, I had to convert all of them into C, and thus it took 4 operations. Now we have A, B, B, C, 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 and 4 of the D's. So C, 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 C. So these were initially D's which were converted to C's. Now the total number of C's that will have to be converted to B is going to be the number of D's plus the number of C's, that is say 8 in this case. Not 8, but I would say 4, 5, 7, right? So how is it 7? It is actually 4 of these C's plus 3 of these C's, right? So 4 plus 7 is the new answer. Now I will have to convert all of these C's into B's, right? So it will take 7 operations, right? Now once I have converted into B, so it will be B, 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 and B, 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 B. So what is the total number of B's now? That is 4, 7, 8, and 9. So all of these B's will have to be converted into A's. So you see, each time I am trying to find what is the number of operations, it is basically all the elements that are after it, right? So this is exactly what I'll have to do. So you can do it in two ways. I have maintained a total variable here, but it is not at all required. You can also like just count in an easy way. I'll tell you how. But first of all, I've just sorted the whole array in reverse order. So what will happen? The bigger numbers, that is D, will first come first, and then all the C's, and then B's, and then A. Right. Now, whenever you encounter a new element, that means all of these previous elements will have to be converted into this particular element. So you can easily find them by just doing what is the position of I. So let's say this is at index 0, 1, 2, 3, 4. If it is at index 4, that means there were 4 elements before it. So here you can see that instead of maintaining a total variable, I could have just added I also, right? So what I'm essentially doing is, whenever I encounter a new element, that means all of the elements that were before it will have to be converted into this new element, and it will take I number of operations. And let me just quickly submit this and check whether this works or not. So you see it passes all the test cases and the solution is absolutely correct. So you don't actually have to do anything in this problem. You just have to figure out what is the position when I encounter a new element. And if I encounter a new element, that means all of the elements that were before it will have to be changed into this new element, right? And you can do it by sorting the array in reverse order. If you just sorted it in like non-reverse order, then you'll have to traverse the array from the back, and instead of adding I, you can add n minus I minus 1, I believe, right? So let me just confirm this. For example, you had D, 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 D and C here. So this is 0, 1, 2, 3, 4, right? The size of array is 5 here. So if you come at this position, you will have to add 4. So that would be n minus 0 minus 1. Yes. So if you do it, like if you sort the array in increasing order, then there are two things. First of all, you will have to traverse from the back, and whenever you encounter a new element, you will have to add n minus I minus 1 into your answer. So this would be the solution of this particular problem. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video was actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So till the next video drops, keep coding, stay safe, bye bye.